my dear classmates. My topic is abstract algebra. So, if you look at the meanings of these words individually, abstract stands for something which exists as an idea or thought but doesn't have any concrete existence. Whereas algebra refers to the part of mathematics where numbers are represented using symbols and letters, and they are used to solve various simple problems and formulas. For example, x plus 5, x plus y plus 1, these all represents the algebraic equations. But what does abstract algebra together mean? So if you go by the name alone, it might sound to the familiar algebra most of us have read in the high school. But if you open a book on abstract algebra, you will be there and for quite a shock because it looks nothing like the algebra most of us are familiar with. So to help you understand what abstract algebra is, let's go back in time. There is 1800, and for some time now people have been able to solve linear equations, quadratic equations, cubic equations, and even quadratic equations. But what about equations of higher degree? Degree 5, 6, 7 and beyond. This question was answered by a young teenager named Évariste Galois. And to answer this question, he used a tool named groups. Around the same time, Carl Friedrich Gauss was busy making discoveries of his own. He ironed out a new technique named modular arithmetic, which helped him to solve various problems of number theory. Now, modular arithmetic shared many similarities with the tool that was used by Galois. Now, the year 1800 also saw various revolutions in geometries, and for more than 2000 years, the scene was dominated by Euclid with his book The Elements. But soon, the mathematicians realized that the geometries are beyond what has been devised by the ancient Greeks. And soon it was realized that groups are really important for us that help us understand these new geometries. Now, it made sense to abstract out the common features of the tool used by Galois, Gauss and others and made it consolidated in a form of study which is known as group theory, and thus group theory was born. Soon, it was found that it's very useful, and it's very common to ask, would they work as elsewhere? So they were used and new objects were identified. Fields, vector spaces, modules, etc. was found. But their definition has to be very precise, because if the definition would be very general, they would be kind of boring and not very useful. And too specific, they would be abstract and they would not be very useful for us to solve the particular problems. And thus, the abstract algebra now be studied as a form of group theory. Group theory is also, the abstract algebra is also known as modular algebra. And if we are ever at a cocktail party with mathematicians, they will simply call it algebra. So, it has various applications not only in mathematics but computer science, physics, chemistry. Every year they are figuring out how these groups can be helpful for us to solve various problems. So, when do you think are you ready to learn abstract algebra? The basic prerequisite is that you must be familiar with the simple algebra that we have studied in the high school, but there are two main requirements: mathematical experience and mental ability. Are you able to think very abstractly? Have you gone through many mathematical proofs? If yes, then abstract algebra is going to challenge you like never before. Thank you.